All right, let's have a little discussion about Project 4. This is the first time I'm teaching the simple linear regression in a Stat 1 environment, but it's very similar to what I used to teach when I taught it in a Stat 2 environment. We've moved the simple linear regression to the first statistics class, and that's what you guys are responsible for. Going through and answering all the simple linear regression questions that I ask you. And basically what I want you to do is treat this like I treated the examples that I went through in class. So we did a couple of examples. I went through and talked about the variables, talked about the printouts, the interpretations of the printouts, and I'm just asking you to duplicate that, except everyone's going to be using the same kind of data, but obviously different numbers themselves. Everyone's working with automobile data. So we're trying to predict the price of a car based on the mileage. You got to sort out which is the dependent variable, which is the independent variable. And then in Project 1, I asked you about your experimental unit. I'm asking it again. It's the same experimental unit you had in Project 1, so go check it out. I show you in my little demonstration video how to generate the printouts, and I want to see your printout here because all the numbers you see on the printout, from the beta interpretations to the standard deviation to the R-squared, all that stuff to the actual tests that we're conducting, all that stuff's on the printout that you're answering questions here. Question 4, interpretation of your y-intercept. Is it practical? Why or why not? We talked about a couple different questions you need to ask yourself before you make a practical interpretation of a y-intercept. Does it make sense in your case? Slope interpretation does. So give me a practical interpretation of the slope. Show me, or talk to me about what that is. Use the words of the problem for all these interpretations. Use the words of the problem. Rise over run. So how does that translate with the variables in your project? The standard deviation, this goes back to the beginning of the semester, right? The standard deviation, we expect most things to fall within 2 standard deviations of the mean. We've talked about how that translates in a regression analysis. So tell me the interpretation as it pertains to your regression. And then this one's new, the coefficient of determination. We haven't talked about that anywhere else, but the R-squared that's listed on your printout. You don't need to do adjusted R-squared, just R-squared. Give me the interpretation as it applies to your data set. And then conduct a test hypothesis. Questions 8 and 9 ask you to state the null and the alternative. We want to test to see if there's a useful linear relationship between your variables. How do we do that? What's the null? What's the alternative? And in your case, it should be a one-tailed test because you're working with automobile prices. You're working with mileages. You should have an idea of what that test is. Get the test statistic off the printout. Get the p-value off the printout. Be careful with your p-value, though. We've talked about that in class. And then state the appropriate conclusion for your test. You choose alpha. Anything between a 0.01 and a 0.10 is appropriate. But give me your alpha, give me your conclusion, whether you reject or fail to reject, and then the words. Tell me the words of the problem as they apply to your variables. And so just a standard test, a hypothesis. You've heard me say it many times this semester. It's just a test. It's a new one, a new application of the test procedure that we've looked at before. Then we have some confidence intervals. We call them a prediction interval and a confidence interval. The printouts that I went through with you, the demonstration shows you how to generate the upper and the lower endpoints for the prediction interval for y, the confidence interval for e of y. I want you to give me the results here and then give me the interpretation. Lead with your confidence level. So it's just a confidence interval, right? Confidence, parameter, numbers. Parameters are a little bit harder to talk about when you're talking about simple linear regression, but don't reinvent the wheel. Take a look at how I did the interpretations when we went through the notes, when we went through the examples in class, and now apply that to your data set. And that's your best approach to giving me the answers for Project 4. So generate the printouts as quickly as you can. And then when you have questions, you know how to get hold of us. Talk to me, talk to the teaching assistants. Good luck.